Okay, so here we're going to start section 1.4, which is called Graphing with Software, and it's basically just learning how to manipulate the window screen on the calculator when we are going to do graphs of functions. So here we have several examples, and all I'm going to do is go over basics of how to figure out what would be the best viewing window according to each graph you may be presented. So use a graphing calculator or computer to determine which of the given viewing windows displays the most appropriate graph of the specified function. So the instruction is basically going to be for every single question the same thing. We want to select the best viewing window according to each function. So we will go, and you have here the answer choices, but even without looking at the answer choices, we will try to first think of what is it that we are looking for. What are the basic features that we need to see for every different type of function, and then based on that we will decide from the answer choices what would be the best viewing window. So for example, okay, here it is, this function, let me see if I put it correctly, minus 1x squared minus 14x plus 24. My window, yeah, okay, sorry, I was doing other graphs and I was changing the window. So let me set back the window to the default. All our calculators by default, they're always in this format. So if you ever change the numbers on the window screen, you can always set it back by pressing number 6. You go to zoom first, you click on zoom, and then from zoom it takes you to this set of options. You will select number 6, or you click enter on the number 6, the option number 6. So this will reset the screen to the factory settings, let's say. So the factory settings is that always our x-axis, it will show us all the values from negative 10 on the left side to positive 10 on the right side. And for the y-axis, same thing, from negative 10 to positive 10 on the y-axis. So you can see this graph, which is a cubic function. It has right here some kind of curve up here that we don't see. But you see, talking about the domain, let's say, which are the x values or the x-axis, I think all we need to see for as far as the length on the x-axis has to be, we have to be able to see something a little bit to the left side of this x-intercept that is at 1, 2, 3, 4, negative 4, probably a negative 4. And then 1, 2, 3 at positive 3, a little bit to the right side of that x-intercept. So we would like to see a little bit to the left side of the x-intercept on the left side, and a little bit to the right side of the last x-intercept on the right side. So then, if I look at the answer choices, the only answer choice that covers something like what I'm telling you would be the last one. That would be sufficient. Talking about the domain, which would be the first interval period, the first interval, I should say, that you see here on the bracket. So 1, negative 1, negative 2, negative 3, negative 4, at negative 5. So we would like to see from negative 5 on the x-axis all the way to 1, 2, 3, let's say 4 or 5 would be perfect, because up to 5 on the positive x-axis we can clearly see this curving and getting wider, right? Maybe at 4 we're gonna cut it too soon, and we're gonna miss a little piece of it, of the curve. So the only option as far as the first interval from these 4 options, the one that looks more like what we need, it's the last one, letter D, negative 5 to 5 on the x-axis. The rest, negative 3 to 3, we are gonna cut things that we want to see, as for example, we're not going to see the left side, the x-intercept on the left side, and we may see the right x-intercept, the last one on the right side, but we're not going to see the entire graph over here on the top, and that's important. We want to see that. So the only thing that we would need to figure out now, after figuring out that probably letter D is the best option for the domain, letter B, negative 20 to 20 is too much. We don't need all the way from negative 20 to positive 20 on the x-axis. And negative 1 to 1, that's too short. It's going to cut important pieces of the graph, important attributes of the graph. So then it's probably the best thing to go with D, but let's verify that the range, this range values are going to be what we need to have. So the only thing that we're missing here on the y-axis is to see where exactly is this graph curving on the top part, or in other words, the maximum on this graph, right? We can see the minimum on this curve right here, but we don't see the maximum on this other curve. So we want to see where that happens. So you go to the window, and let's see, I'm going to try the domain that we set. For the x minimum, you put -5. For the x maximum, you put 5. So that's saying I want to see the x-axis on the left side starting at the number -5, on the right side ending at +5. Then we switch to the y minimum, which would be -10, and the y maximum would be 50. We graph. Let's see if that shows all the attributes. Yes, you can see a way better picture than the other one. You can see the maximum in this curve, you can see the minimum on this curve, you can still see the x-intercepts. Here we saw how this curve, the second curve to the right side, is really crossing the x-axis, right? And then from the top to below the x-axis, and then it does the same thing from below, it goes to above the x-axis. But anyway, this gives us a better idea of how the graph is supposed to look like. All the other windows, if you try them, some of them are going to make the graph to look really tiny, that you're not even going to be able to see all the attributes, as I was saying, and it's going to cut too much. And other ones are going to do some very large domains and range, but the graph is going to look tiny, tiny, tiny. And other ones are going to cut too much from the graph that we need to see. So here the best viewing window is this. So all you have to do is graph whatever equation you're given in terms of a polynomial equation like this one, and then just see, like, okay, what piece of the graph is not appearing on the screen? What would I need to do? Do I need to increase the y's on the positive sides of the y's, or on the negative side of the y-axis, or maybe the x-axis? What is it that I need to fix or change, right? So that would be letter D for this one. For the next problem, the instructions are going to be the exact same thing. So now let's graph this, and let me move this here. And I'm going to go back to the factory setting. So I'm going to go to zoom. I'm going to put 6. It's going to set it back the way that it used to be. And this is the other one, right? Now we want to graph this new one, so let me clear this. X to the 5th minus 5, x to the 4th power plus 20. So you can see the same thing. It's curving somewhere over here on this part of the top, and there's also a curve at the bottom on the right side. So we want to know what would be the best viewing window. And here we have several options, right? Like, for example, there's some that you just see and you can discard them, because obviously that's based on what you see. Even though you're missing some pieces, you can tell that letter C and letter D are not going to be the best viewing windows. Letter C is cutting the top part of this curve, which we want to see. And letter D, it's not even showing you the lower curve, which we want to see also. So C and D, no, it's taking off some attributes from the screen that we need to see, that are important. So we're between A and B. Probably I'm thinking that the best one may be B, C. It's the same thing, but A is like zoomed on a certain piece, and B is like the perspective is like you're a little bit farther away from the screen, right? So let's see which one would be the best. Let's put it on the calculator. Okay, so here, sorry, my calculator kind of got stuck. So I will go to the window and see, I'm thinking that the best one already out of this two is probably A, because even though B, it's not that it's not a good picture of the entire graph, it is, but it's too far away. We would like to see attributes in a better way, in a closer way, as for example the x-intercept, as for example exactly what the y-intercept, if it is possible to appreciate it in a better viewing window. So then I'm going to go with the first one, -3 to 6 for the x-axis, and then -300 to 100 for the y-axis. And you can probably agree with me that this is way better than looking at the same graph but super far away, where you cannot really see the x-intercept or the y-intercept. This is by far a better picture than letter B. It's not that letter B, it's not the correct graph that corresponds to this one. Yes, it is, but it's from a farther view, and we would like to see everything as clear as possible. So this would be the answer that we are looking for. That would be the best viewing window, okay? That would show very clear all the attributes as far as x-intercept, y-intercept, and it just gives you a better picture of the graph, okay? So that would be that one. This next one, let me graph here x, and then the square root of 25 minus x squared. Close the parentheses. Let me change already to factory finish, to standard. Okay, so this is what we see. Now, I need to see where is the maximum point of this curve, where is the lowest or the minimum point of this curve, right, on the left side. So see, letter A shows something very similar to what I have here. So obviously letter A is not the best option because it's not showing the whole thing. Letter B cannot even be the graph that corresponds to this function, because it's completely reflected over the y-axis. So it's not the same graph. This graph on letter B does not correspond to that given function. Then between C and D, D cannot be. You can look at D. It's also not in the same position as this graph. So by critical thinking, I mean, it cannot be any of the other three, right? But just to be on the safe side and to make sure that if I would change the window domain and the window range on this screen to the numbers that you see here on letter C, so for the x-axis I want to put negative, it was already negative 10 to 10. It's the y that is changed. And of course, that's what you would want to change, instead of negative 10 to 10 to negative 15 to 15, because the only thing we don't see is the top part of the curve or the bottom part of this curve, the maximum or the minimum of this curve. And if you increase or you do a bigger range that shows you more y values, instead of from negative 10 to 10, from negative 15 to 15, you can appreciate better those pieces on the graph. And so yeah, that's the only one. The rest of them could not even get close to what the graph of this function should be. Okay, so you can see that in a lot of these questions that I'm doing, it's sort of like perception. It's what you see, and you will decide how you will be manipulating the x's and the y's for you to see a better graph. Now, on this, there's not a set structure that I can give you. Yeah, every time you have a function that has a square root, do this. Every time that you have a cubic function, do this. It's just based on what each of us see. And if you don't have answer choices, what will you do? Start playing around with the x-axis and with the y-axis until you think that the picture that you have gives you a better idea for whatever the purposes of other question may be in another chapter section later. Maybe later it's going to be, what's the x-intercept of this graph? And maybe you graph the function with the standard viewing window, the negative 10 to 10 on the x and the y. But then it's missing to show you the x-intercept, or you cannot clearly see it. So you're going to start thinking, how do I change the window so that I can see this attribute that I'm being asked about? So this is just showing you how to use the technology to your advantage for other sections where you may need to graph and you want to be able to see the answer from the graph without having to show your work for a particular question. So this one, it's an absolute value function. Where are you going to find this symbol for the absolute value? At least on this kind of calculators, you will go to Math, and then you will go to the right side to the menu that is called Num for numbers, and then write the first option, number 1, it's called abs, that's the abbreviation for the absolute value, and then you put x squared minus 7, and you close the parentheses right after the 7, right? Then you hit graph, this is our graph. Which, by the way, it's not a bad graph. I mean, just with the regular, and is it the regular already? Oh, remember that I had changed this? Let me put it back to -10 to 10. So this is what you would see if you are using the factory settings of the calculator, which I'm telling you, it's not a bad graph. You can probably tell the x-intercept and the y-intercept, and you can see the complete graph. But in here, they're just trying to be perfectionist, I guess, so they want to see which one would be the best viewing window. So I say letter B, definitely no. It's not even the graph that corresponds to this function, right? So we can discard that one. Then C has nothing to do, right? Like C is, I don't even know what kind of graph was that, has nothing to do with this function. So we are between A and D. Now, look at the difference between A and D. You can see that on this graph, it looks like these little minimums that you see here, or the x-intercepts, are actually like, they're in x-intercepts because the graph is touching the x-axis right there at this negative number and at this positive number, which is in between integers, right? So I don't think it would be letter D. I'm thinking it is not. But to be on the safe side, you can try to zoom in on this part. How? You would shorten the x-axis and you would shorten the y-axis. You would limit it a little bit more. Maybe that's gonna help. But mainly what's gonna help, it's not so much fixing the y-axis. It's going to be shortening the x-axis so that you can kind of do a zoom in on that section. And if you look at answer choice A, that's what they did. Let's put here -5 to 5. Okay. I'm not gonna change the y's yet. I'll come back right now and change them. But I just want you to see that just with that, everything looks clearer than before. Now let's do the same y's, -5 to 15. So I can clearly see that the graph is touching the x-axis. That is not like it's, let's say, right above the x-axis without touching it. It is actually touching it, so it cannot be this one. This is the graph that corresponds to this one, and it's the one that from these answer choices would give us the best viewing window. But if I wouldn't have answer choices and I want to see the x-intercepts, I want to see if the x-intercepts are at exact integers or maybe in between certain integers, then what you are looking to do is shorten the x-axis so that you can do a zoom in on that section. And maybe shortening the y-axis could help. As you see here, they shorten the negative side of the y-axis, even though they increase the y. So that would be that one. This one right here. How do you enter a rational function into the calculator? It's very important that you do not forget you need parentheses around it, on the numerator and around the denominator. If you do not enter the parentheses, you will not graph the actual function. You will graph a different kind of function that is not going to correspond to this one. So because I was changing the window right now, again, let me go to standard, number 6. So obviously, this is not a very good graph, right? We want to know exactly what's going on here in the center. So you have to select what would be the best thing to do. Again, I say shorten the x-axis without even looking at the answer choices. My instinct or my cognitive sense is going to tell me to shorten the x-axis, to try to zoom in on this piece. Probably shorten the y-axis too, so that I can really do a zoom in or a close-up on this section right here. So I guess you can agree with me. Letter B definitely cannot be the right answer, right? That wouldn't be the best picture or the best viewing window. D, also, it's out of the question. I don't think C is going to be, because C is probably something worse than what I see here, right? It's not very clear to me. I'm thinking the best viewing window is going to be the first one, where they do what I'm telling you. They don't make the x-axis bigger, because the more you extend it, the farther away the picture is going to look. So you don't want to do that, right? We just said we want to shorten the x-axis from -7 to 13. And these numbers are chosen at random. I mean, someone else may put from -6 to 12, and it's fine. If you don't have answer choices, this is the kind of thing that you want to be able to figure out on your own. These are just examples that have multiple choice. But if you don't have them, then just use numbers at random. So yeah, this is the one that would be the best viewing window. It definitely looks better than the other one we had. And this is the only answer choice that matches actually what we see on the calculator. The rest, at least B and D, were completely out of what we were supposed to be. And C was the right graph, but from a too far away viewing. So we wouldn't want to say that's the best viewing window. It would be A. For this next one, same thing. Remember, parentheses around the numerator, parentheses around the denominator. Every time you are going to enter a rational function. So on the calculator, x minus 1 in parentheses divided by x squared minus 2x minus 15. So you graph it. And remember that I was changing the windows, right? So I probably need to do, just to see how it would look using the factory settings, which I think the other window was better, right? Factory settings, look, this doesn't look that good at all, right? This here are vertical asymptotes, right here. If you recall from college algebra how to find vertical asymptotes are found by you setting equal to 0 the denominator of this rational function and solving for x, which means by factoring it out. So if you do x squared minus 2x minus 15, and let's see if it is factorable, x times x is x squared, and we need to find two numbers and multiply, give me 15, and subtract it, they're equal to 2, so 5 and 3, 5 times 3 is 15, 5 minus 3 is 2, minus whatever the sign is in the middle term, you put it on the first one. You have a minus at the end or a difference at the end. The second sign must be different or the opposite from the first one. So in college algebra, we go through factoring this trinomial to be able to solve for x. So here, this would be my two vertical asymptotes at x equals 5 and at x equals negative 3. So that's a very important attribute from the graph. Plus you see the picture. So I would like a viewing window that would show these two vertical asymptotes as a minimum, right? There's other attributes here, but as a minimum, that's what I would want to see. I don't think letter A is showing you properly those vertical asymptotes. I don't think B is showing them either. C and D could be, but which one is better or which one is worse? So at negative 5, there is a vertical asymptote, which here on D, I can clearly see that. Maybe on this one too, on C, but for some reason, maybe D looks better, but we'll see right now. So then, I'm sorry, at negative 3 on the left side and at positive 5 on the right side. I don't think you want to go with C because look, C, it's going, not every little mark here is not 1 unit. It's going by 5, 10, 15, 20, 25, negative 25. So it's going by 5. You cannot really tell, for example, when there is an x-intercept very clear as if you're going 1 unit by 1 unit, or maybe for identifying if the asymptotes are placed at the right unit on the x-axis. I think with this one it's better to tell that this may be negative 3 and that this may be 5 than when your scale is not 1 by 1. But let's see. Let's see once on the calculator which one would be the best viewing window. I'm going to try the first one, okay? So the x-axis goes from negative 25 to 25. Now the thing is, what is the scale here? It's not going 1 by 1, it's going by 5. So here, x scale, you put 5. Now for the y-axis is negative 10 to 10, and they're also not going 1 by 1. If you see, they're going by, what is it that they're going by? Are they going by 5? Let's say by, they're not going by 5 because negative 10, they're saying it's all the way down here. So I'm gonna put that they're going by 5, even though you can tell that probably they're not. Maybe yes, maybe this -10 is for this little second line. It's because I see a third line here, and I don't know exactly what that would be. It looks like another little mark, but let's say that they're going by 5s as well. Let's see if they are going by 5s, it's still too far away. -25 to 25 by 5, -10 to 10, assuming that this is really going by 5. I don't think it's the best way to go. We cannot even see anything. They probably zoom in too much to show us this. So probably the best one is going to be letter D. So here we say from -8 to 10. And this one is going by 1 on the X scale. And then -10 to 10. But this one is also going by 1. That's better. Now let me tell you something. In this version of calculator, as the versions of this TI calculators are newer, the pictures come out better. Here, I know you say, but what happened to this piece right here, like this and this piece? I don't see that on the graph. Okay, and here in the center, it's not even showing you exactly what it's supposed to be. It looks like, is it cut here in the middle or something? This, at least this old calculator version that I have here, that's the way that it shows it. As the calculators get newer and newer, they do a better picture of the graph. But in reality here, this graph, don't think that it's just going up to here and stopping and being cut. Actually, this should have been going up in an infinite way. And then it's curving, crossing here through probably the x-axis through 0, 0, and then going down here in an infinite way as well. So even though it's not the ideal graph, right, because it looks like it's missing pieces of it, but this older version, that's what it does. If you have a newer calculator, it may show this same picture but better. Then according from the answer choices, I would go with letter D. I would not choose D because you saw that it's too far away. So from the worst, the best would be this one, right? That's what I would say. So then that would be it for this one. Now for this next one, it's also a rational function, so we want to be using parentheses around the numerator and denominator. So parentheses 5x squared minus 50x plus 120 divided by 2x squared minus 16x. So, and then we put the screen the way that it's supposed to be in factoring settings. So in factory settings, this is what you would see if your screen is -10 to 10 on the x-axis as well as on the y-axis. So now you see that there's a piece of the graph or of the function over here to the right side that we cannot really tell exactly how it is, right? So probably if I were you, I would want to move the x-axis more to the right side a little bit to show me something after 10, whatever number you would like to choose, right? That's something I would do. I could probably cut a little bit the x-axis on the negative side and I may still be okay. And there are here two vertical asymptotes, right? There's one here on the negative side of the x-axis, there's one here on the positive side, and there's probably here even a horizontal asymptote. So now, from what we have from the answer choices, I told you what I would do if I wouldn't have answer choices. What would I choose from here now? Letter A, definitely not, right? That couldn't be the best viewing window. Letter C could not be the best viewing window either. So at this point, we're between B and D. So the only thing that I find different from B and D is that D shows a better portion of both sides of the top pieces of the graph, of these two curves, while B is cutting too much of the left side piece, and that probably is the reason that we wouldn't want to go with this one. So I'm thinking this would be the best viewing window. Let's just make sure that this is actually this one, right? It looks like this, like it matches, but let's put here, it is from -10 to 10, already, the x and the y. So then, yeah, that pretty much looks like that, right? This other one, I'm telling you, the reason that I would not choose it is because it's cutting too much on this piece on the top. Only because of that. But it's not that it's not the right graph for this. It is. It's just that because the x-axis is longer than here, it's going up to 15 on the right side, and they shorten too much this x-axis on the negative side. They cut it up to -5. It's too much. That's why you cannot see very well this piece. So letter D would be the right answer, the best viewing window. Now this one, what about the trigonometric functions when you graph it? Okay, so let's graph. Let me change this to the regular standard viewing window, and then let me enter the new graph. Then we will put here in the y equals sine of 50x. Let's see what you would see. Oh, you would see this. Definitely not the best graph, right? Because we cannot even see exactly what's going on, how that graph is curving, and so forth. So for trigonometric functions, for you to determine the best viewing window, at least for the x-axis, okay, this is what you will always do. Identify what's the coefficient in front of this x, in front of the variable, okay, and you will do the following. You will determine what is the period of this function. So sine is periodic every 2 pi, right? So you will do 2 pi divided by the coefficient in front of the x. You may put this into your calculator, or you may leave it as a fraction. If we do it without the calculator, then this reduces to pi over 25. If you notice, that number, it's the number they're using for the left side and the right side of your window domain, right? Now, why are they using -2 and 2? Because what's the amplitude in front of the sine function right here? It's a 1. There's a 1 in front of the sine if I don't see it. So probably instead of just cutting it right at 1, they're just giving it a little bit of more space on the range. So 1 unit higher, 1 unit lower, just for you to have a better picture. Okay. So then this will be the number that will show us what the domain is going to be. The domain, or how you're going to restrict your x-axis, it will be using the same value, but starting with it on the negative side and ending with it at the positive side. We know that one cycle, or one cycle of this sine function would be from 0 to 2 pi. That's one period, right? Because we know this function is going to repeat itself every 2 pi, every 2 pi. But because we are interested in probably having a best view, not only from 0 to 2 pi on the x-axis, not only on the positive side of the x-axis, I guess what they're trying to do here is show you one period on the left side, from 0, let's say, to -2 pi, and from 0 to 2 pi. But because this is not the regular sine of x, if this function was simply sine of x, then yes, we can say it's going to be from -2 pi all the way to 2 pi, and this will not only show us one period or one cycle, but two of them. From 0 to the -2 pi on the left side, and from 0 to 2 pi on the right side. Because this is a transformation, it has a number in front of the x. We're not going to go with -2 pi and 2 pi. You will actually divide 2 pi by that number to determine the period, I don't want to say the period, but two periods, because that's how they're doing it. They want to show you two periods on the graph, one on the right side of the x-axis, one on the left side of the x-axis, from -pi over 25 to 0, and from 0 to pi over 25. So to determine how you're going to set the x-axis, that's what you will do for trigonometric function. You will, sorry, I wanted to go to the window. You would want to divide whatever the period of this function is, by definition, by the coefficient in front of the x. So on the x-axis, you will put negative, and you're going to type it exactly the way you see it, -pi over 25. But you know, for pi, you need to put second pi. Second, and then you click on the pi over 25. It's going to change it to decimals, but it's okay. It's fine. Now, For the y minimum and y maximum, we know the amplitude is 1 because that's the number in front of the sign, but just give it a little bit of more space on the top and on the bottom of the graph, so that's why they're putting negative 2 to 2. So let's see which one would show us the best picture. So which one is the one that actually matches this? Not the first one. Not this one. This is upside down. Look how it's supposed to start on the very left side on negative pi over 25. Increasing, right? And this one is decreasing here. This one, no, cannot be. So the only one that matches is letter D. This one. The rest, they're all graphs of probably a different function or not showing you that it's based on the x-axis according to using this little strategy that I'm telling you. So for every trigonometric function, this is the process you will do. What's the period of this function? Okay, 2 pi or pi, because you know some of them will have a period of pi and not 2 pi. So 2 pi divided by the number in front of the x, and that's it. Okay, and that definitely looks way better than the one that I had when the window was in factory settings. Okay. Next one, same thing. Let's determine what's going to be the number we will use for the x-axis. So again, it's the same function, so 2 pi divided, what's the number in front of this? You can rewrite it as in this form, 1 over 45x, right? Multiplying times the number. Whatever it is the number, multiplying times the x. So you divide these two numbers, which you know you could change it to 45 over 1, right? Do the reciprocal of this one, flip it around, and you multiply across. So you can put this one over 1 and multiply it like this. So 2 pi times 45, right? Over 1, I don't think 1 times 1 is still going to be 1, right? And 2 times 45 is going to be 90 pi divided by 1 is the same thing, 90 pi. So which ones show that for the x-axis? Not B, and I don't think that would be the best picture, not C. So we're between A and D. Those are the only two that have their correct restrictions on the x-axis. Now let's see which one is the right one. Let me change this to factory settings, to standard form, and I'll type the new function right now. I go to the y equals, we put sine of x over 45, graph it, let's see. What do we see? Which is not very good. We cannot really tell what's going on. Looks like there's a lot of missing from this graph. So go to the window, put from negative pi, I forgot to write that down by the way, that the domain here would be from negative pi to 90 pi, right, for the x-axis. Here 90 pi. Again, what's the amplitude here? 1. So make it from negative 2 to 2. Again, just leave it a little bit of more space. And let's try to match it to the right one. So could this one be it? Easily could be, yes. Could this one be it? Nope. Because if I have those same restrictions as letter D is showing, the graph should not look different. This is the only one that matches. So this is the one, not this one. Correct? Okay. Next one. For this one, looks a little different than the other one, but you have a trigonometric function right here. Let's graph the original first, using the original settings. And let's see how that looks, and then we'll figure out what we need to do. So x plus, look what I'm going to do, in parentheses, 1 over 20, because it's a fraction. I suggest the fractions, you always put them in parentheses, especially if your calculator is as old as mine. 30x. Okay, so I graph it. It looks like, you may say, this is a line. Is it going to be a line? Yet, you know, it has a piece of this. Maybe x, yeah, it's a linear equation. But this second function, 1 over 20 sine of 30x, is a trigonometric function, so it cannot be a line. Probably what predominates here more right now, from looking at this, is that This looks so straight that it may look as a line. But if we zoom in, we may realize that it's not really a linear equation. It should not be, because there's a trigonometric function here. This is just because we're seeing it from too far away. So what you'll do is the same thing. Use the number in front of the x. And so what's the sign again? The period of sign is 2 pi. Divide by 30. So pi over 15 when you reduce, right? So as I said before, that would be what I would set my x-axis to show. From negative pi over 15 to pi over 15. For the y-axis this time, technically the number in front of the sign is the amplitude, right? But this x here that is being added, this, which is a function, this number, it's not like a vertical shift that shifts the graph higher or lower. If this x was a constant, was a number, then it is a transformation where the graph is shifting up or down. But here, no. This is a function that is being added to this one. So if you, just to see what the amplitude would be in decimals, 1 over 20 would be 0.05. You may want to use 0.05 as your amplitude, negative 0.05 and positive 0.05. And I'm not saying that that is wrong, right? The letter A actually has, oh no, it's on the x-axis. I was thinking, yeah, I just thought, and it's not even the same number. This would be, I'm talking for the y-axis, right? But I don't see other than the first one that has 0.05 and negative 0.05, but it's not even for the amplitude, it's not even for the y-axis, it's for the x-axis. Nothing from these answer choices has this to be your range on the y. So I'm going to hold on to that. But if this x, let's say, wasn't here, if the function was only this, then I could use something a little bit higher than 0.05 or negative 0.05, right? Because we don't want to cut the graph up to exactly the highest and the lowest point of the curves on the sine function. So let's see. Let's start by first. Okay, I have that. I had already put it in regular form, in standard form. So go to the window. Let's type negative pi over 15. And then pi over 15. Now, I don't think the range, we should leave it as big as negative 10 on the lowest part of the y-axis and 10 on the highest part. So let's just see, what if we choose something a little bit bigger than what you had here. You had 0.05. So it's not even 0.5, right? It's 0.05. So that's why probably you see these numbers here. Negative 0.21, 0.21. I mean, I don't know, right? But let me go back to here, to here. When I put negative pi over 15, what was that number equal to in decimals? It's equal to negative 0.21, right? Or 0.21, 0.21, which is the y values that I see here on letter C. That just caught my attention. So I'm thinking they're trying to do this as a square, right? Like they're showing you the same distance on the x-axis and the same distance on the y-axis. Let's see if we try that. And 0.21 and negative 0.21, it's definitely giving you more room than 0.05, which would be really tiny here, small, or negative 0.05, which would be really, really tiny. It's something higher than that, it's something lower than that. Just like what we did on the other one, the amplitude is 1, and we don't show the y's from negative 1 to 1. We show them from something lower than negative 1 and something higher than negative 1. So probably here, since this number is a coincidence that it's also a bigger number than 0.05, they went with the same as this value already for the y. Let's put it here, negative 0.21 and 0.21. What do we see? Yep, we see that one, right? That is definitely this graph. This one that was looking at the line at the very beginning, no. This one that still does not really show me the true shape of how this graph is behaving, no. And this one doesn't show me anything on the negative side. Well, this one shows me a better picture from both sides of the x-axis on the negative and the positive side, and still looks not tiny enough, like it shows me a good picture. So then C would be the right one. So see what, how interesting it is in here that what they did with this one. They used the same values for the x-axis and the y-axis. And you determine first the values for the x-axis by doing the same thing as in the other trigonometric functions, the period divided by the number in front of the x. And then that's what you use for the y as well. But just make sure that the amplitude of this function, in front of this function, the number, it's a number that is actually smaller than this, right? That these values on the y's are going to give you enough room to see beyond higher and lower of the actual amplitude, which was 0.05. Okay, so that would be that. For this one, okay, let me change this to factory settings. We graph negative cotangent. Now, keep in mind something. There's no cotangent here, not on this all version calculator. So you need to graph the reciprocal of this one, which is 1 over tangent. 1 over tangent, well, and actually negative. And you know what? Let me put a parenthesis around this. Negative parenthesis 1 over tangent is the same as cotangent because it's the reciprocal of it. And the negative, make sure you put it at the front of the parenthesis of 1 over tangent. If not, it may not graph the exact same thing. So negative parenthesis 1 over tangent, which is supposed to be the same thing as cotangent x. You close the parenthesis for the x and you close the other one that we opened at the beginning. When you graph it, this is what you see, which is not bad, right, for a graph. But maybe we can do something better. So D is out of the question. I just saw D right now and I'm like, no, that has nothing to do with the actual graph. Then look at the negative cotangent graph here. It's curving from the left side. It's increasing, rising towards the right side. I think A is completely the other way, right? It has another direction, so it cannot be that one. B, I don't think B is going to be. It has nothing to do with this. The only one that may look like this one would be C. Now they're showing only these two tangents, these two pieces of the tangent to the right side and these two to the left side. So they're definitely shortening the x-axis, right? If we are assuming that this is going one by one, which we're not very sure, right, that it is, but probably it is going like that. It's 1, 2, 3, 4, 5, and 6. Let's see. Negative 6 to 6. And at the bottom, 1, 2, 3, 4. So I'm going to go with negative 4. Actually, negative 5. This is a negative 5 to 5. 1, 2, 3, 4, 5, 6. Yeah. Let me do an extra one here so that you can see this little piece. Negative 7 to 7. Yeah, see? That's what they did. Exactly what they did. This little piece is this one, this little piece is this one. So even though it was 1, 2, 3, 4, 5, 6, I went one more to 7 over here, just for me to see that. And that's the one. Here, you didn't have to do, let me divide pi, which is the period of this one, pi over the number in front of the x, because it's a 1, right? So basically this function is periodic every pi. And here they showed actually more than one period. They showed 4 periods, right? 4 cycles. Okay. 2 to the left side of the x-axis, 2 to the right side of the x-axis. Okay. This last one. Okay, let's go to the regular settings, and then we'll type this last. Then you go to the y-axis, sine of x minus cosine of x. Minus 2 cosine. I was going to forget about the 2. Minus 2 cosine of x. Graph it. This is what we see. Letter B, out of the question, right? I don't think that could be it. Not letter B. Now let's think of this. How can I figure out the best viewing window? Let's see if when we do, I'm going to try letter A first. If when I do this arrangement on the X and the Y, I truly see this. If it doesn't even look like that, that couldn't be right. -8 to 8, -4 to 4. And assuming that the scales are going by ones, right? Which that, we're just assuming because we cannot really tell. But does this look like this one? If it is set from -8 to 8, from -4 to 4? Not really. No, right? It has nothing to do, completely different. Look at how it starts on the left side. It should start higher up here if this is -8 and this is also -8. So this cannot be either. So let me put it back in factory settings just to see, go back to where I was at the beginning. So we are between these two. Now let me tell you something. I do not think definitely that C could be the answer. Where could you tell that right away? Look at this here, from the on the x-axis on the negative side. The negative side is curving down and then rising and then curving down again. But look at this one. This one starts high up here on the y-axis and then it curves down, but on top of the x-axis. This is below the x-axis. C couldn't be at all. I think it has to be this one. If you look here at 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so here your window is going from -8 to 8 for the x-axis or the domain, and for the range they're choosing here 1, 2, 3, 4, let's say. So from -4 to 4. So when I set it up, mine in this format, this is the one that I was seeing, but I was just focusing on checking A right now, so I didn't even turn to see letter D. Let's see here, just to put it again. Pretty sure it's going to be the one. Yes, you can tell it is exactly that. Okay. So for this one, all you had to do, was trying to cut the x-axis into, instead of -10 to 10, to something shorter than that, and then the y-axis, instead of -10 to 10, again, cut it into a smaller section from -4 to 4, and that is gonna make the graph to look like if you're zooming in on it, and you can see better. So here they didn't choose any number in particular. They didn't do, oh, what's the sign of the cosine? 2 pi over 2 or something, because that would be pi. And pi is 3.14. That's not what they're using for the domain. They're not saying from -pi, which is 3.14, to pi, 3.14. They're not doing that. They just chose numbers at random to cut this, just to do a zoom on it. And by doing a zoom in on a graph, you have to cut the x-axis into a smaller section and the y-axis as well. And that's all they did at random. They chose numbers to cut the x-axis, numbers to cut the y-axis. But other than that, that's it. I guess they didn't do that here because you have two functions, sine and cosine. So which number in front of the x-axis do you go by? With the 1 in front of the sine of x, or the 2 in front of the x of the cosine of 2x? I mean, so that's why they didn't really go by any of that rule of dividing the period by the number in front of the x. You do that in problems where you have a single function, as this one, for example. That would work. Or here, where there's not another trigonometric function. There's another function x, a linear function, but it's not trigonometric. And this one was so simple, right, to graph. You didn't even have to go throughout that process in the previous problem. And on this one, you don't really want to do that because you have two functions. So which one do you use to do that, right? So this is it. This is section 1.4. You can see it's really simple. All you have to do is learn to manipulate the calculator, and that's it. So this concludes this lesson. You'll be ready to do the homework with this and also the quiz, okay? That corresponds to to the sections that also include this. Okay. Hope you like this video or that you found it helpful. Thanks.